These are some review problems for Chapter 4. This was all about probabilities. So the first problem asks which of the following are valid probability values. Probabilities have to be between 0 and 1. Or if we're thinking in percentages, they have to be between 0 and 100%. If we look at this list of values, we don't have any percentages in here, so we're just looking to see whether they're between 0 and 1. This one's good. Between 0 and 1 includes the 1s, so 1's okay. Negative values are not okay for probabilities, so that one wouldn't work. 0 is fine. 1/5 is fine. 1.27, that's bigger than 1, so that one wouldn't work. The ones that are valid are these 4. Next question is that you are in a group of 225 students that entered a contest. If the winner is to be randomly selected so that each student is equally likely to be selected, what is your probability of winning the contest? If each of the 225 students is equally likely to win, that means that your chance of winning is 1 over 225. For the next one, in a poll, respondents were asked whether they were planning to vote in the local election. 152 respondents indicated that they were planning to vote, and 232 said that they were not. Based on these results, what's the probability that a randomly selected member of the population is planning to vote? What we need to do is take the number that said that they were planning to vote and divide it by the total. This didn't give us the total, so we're going to have to find that by adding these two together. Our total would be 384. So for this one, we're going to take 152 and divide by 384. This problem didn't tell us what form to put the answers in, so we could write it as a decimal and round it to a certain number of decimal places, or you could put this in your calculator and use the frac function to have it convert it to a fraction. In fraction form, it would reduce to 19 over 48. Then we also want to look at the probability that the selected member is not planning to vote. For this, we could either take the answer we have and subtract it from 1, or we could just use the other value, which was 232, and divide that by our total of 384. This comes out to approximately 0.6042. If we add these two together, we should get 1, since they're complements. Or if we write it as a fraction, it would be 29 over 48. And again, these two together should add up to 1 because we only had 2 possibilities here and they're complements of each other. For this one, we had a group of 392 college students. First, we want to find the probability that a randomly selected student is female. So we had these divided into men and women. The total number of women that we had was 214. If we're just choosing one student, then the probability that it's a female is going to be 214 divided by 392. That would give us approximately 0.5459 as our probability. Now we want to find the probability that the student is a woman or a heavy drinker. This is where we have to use the addition rule because of the or. We can look at the total of the women, which was 214. We can add that to the total of the heavy drinkers, which is 11. When we did that, though, we counted these 6 people twice. That means we have to subtract off the 6 so that we won't be counting it twice. If we combine these, we get 219. Then we're going to take our 219 and divide it by our total of 392. That would give us approximately 0.5587. The other way we could do this one is look at our table and just circle all the cells in the table that meet one of these two conditions and then add those values together. We'd have all the women plus the heavy drinkers. So we would take 187 plus 21 plus 6 plus 5, and that would give us the same answer that we got here. Next, we want to find the probability that the student is a non-drinker and a man. This one is an and instead of an or. This is actually easier because all we're looking for is where these two intersect in the table. So we have the non-drinkers is this row, and the men is this column. Where those two intersect is these 135 people. Those 135 are both of these things. So the probability that we get one of those people is 135 over 392. That gives us approximately 0.3444. Last of all, to find the probability that the student we selected is not a regular drinker. The easiest way to do this one is to look at how many regular drinkers there are. There are a total of 59. The student being not a regular drinker would be a complement of that. We can take 1 minus our probability that they are a regular drinker, and that gives us the probability that they're not a regular drinker. This would give us 1 minus approximately 0.1494, so this right here is the probability that they are a regular drinker. If we subtract that from 1, we get approximately 0.8506. For this one, we've got an event B, and the probability of that event is 0.42. We're trying to find the probability of B complement. Remember, when it has the line over it, that means that's B complement. If we know the probability of B, we can find this probability just by subtracting from 1. All we have to do is take 1 minus 0.42, that gives us 0.58. That's the probability of B complement. For this one, we have a bag of candies that has 20 red, 25 yellow, 15 green, and 40 blue candies, and we're going to select one candy randomly from the bag. But first of all, what's the probability that our one candy is red? For all of these, we're going to need the total number of candies that we have. So if we add 20 plus 25 plus 15 plus 40, that turns out to be 100. To find the probability that our selected candy is red, we take the number of red candies and divide it by our total of 100. That's going to give us 1/5, or in decimal form, that would be 0.2. The probability that it is red or yellow, these two things are disjoint because a candy can't be both colors. So all we have to do for this one is take the two probabilities and add them together. We have the probability of red is 20 over 100. The probability of yellow would be 25 over 100. Adding those would give us 45 over 100, or 0.45. Last of all, the probability that it is not green. The probability that it is green would be 15 over 100. So to find the probability that it's not green, since these two are complements, we could just take 1 minus 15 over 100. That would be the same as 1 minus 0.15, which would give us 0.85.